Now we start with a new topic, angle modulation. Angle modulation, non-linear modulation. Non-linear modulation. Previously we will discuss amplitude modulation, which one is linear modulation. We start with same idea, carrier frequency. Carrier frequency Ct equals to a cos omega Ct plus phi, some frequency and phase. If we vary this component, amplitude modulation, we vary this component, frequency modulation, and this variation is phase modulation. Combinedly this is known as angle modulation. Any of these two components vary according to amplitude of message signal is angle modulation. This is basic unmodulated carrier component, unmodulated signal. Major component of angle modulation practically used is frequency modulation. Phase modulation is not practically used. Now we will discuss two portions of angle modulation separately. Frequency modulation first. Frequency modulation. Idea for frequency modulation is FM is defined as the process in which the frequency of carrier is vary according to frequency of carrier vary according to amplitude of message signal. As we say, we write in term of expression, FM is defined as the process in which the frequency of carrier vary according to amplitude of message signal, according to message signal. We expand this expression removing proportionality constant kfmt, where kf is known as frequency sensitivity. We can determine unit of kf also, radian per second kf, means unit of kf is radian per second upon volt. If we take message signal as a volt, maybe it current. Generalize with message signal may be in voltage term. Kf indicates change in the carrier frequency for 1 volt of message signal change. 1 volt of message signal change. If kf is 5 radian per volt, means a FM block vary in this way, 5 radian per second volt. Apply message signal on it and resultant is this variation, FM waveform. If MT is 0, means we get result in frequency, instantaneous frequency is omega c, basic carrier component. If m equals to 2, instantaneous frequency omega c plus 10, because 5 multiplied with 2 is 10. If mt is 5, omega c plus 25. Mt is minus 5, then omega c, means frequency oscillate between around omega c up to some amount, is known as instantaneous frequency. Means voltage variation in the voltage input signal, voltage variation converted into frequency variation. It is known as frequency modulation. Frequency modulation is basically frequency converter. Voltage variation converted into via FM converted into frequency variation. It is known as frequency variation, which is known as voltage variation converted into frequency variation. Practical example of voltage to frequency converter is VCO, voltage control oscillator, because oscillator produce frequency on the basis of variation in the voltage. If MT is 0 and move in positive direction, instantaneous frequency is omega c plus deviation. MT move in negative direction means instantaneous frequency is omega c minus del omega, means instantaneous frequency vary around carrier's frequency. It is known as frequency modulation. In AM, what is the basic difference between AM and FM is if MT is 0, carrier amplitude is A. If value of MT message signal is some positive magnitude, then envelope is now changed. Envelope value, envelope magnitude. If negative, 1 minus mu, means it is oscillate between a 1 minus mu maximum and minimum value of voltage. This much of amount of variation. This much of amount of variation. Twice a mu. Now the basic idea for frequency variation is generate this expression. It shows variation of voltage convert into frequency variation. We start with definition. Our definition is MT applying appropriate proportionality constant. The definition is now converted. Now we can calculate frequency variation for any instant. Frequency variation KFMT. This frequency variation always measure in term of maximum value, because it is not constant term, so we calculate in maximum term. Maxima is of this component, which is important parameter for angle modulation or frequency modulation, is frequency variation. Maximum frequency variation is second important term, maximum phase variation. Relation between phase and frequency is theta equals to omega t. D theta dt equals to omega. From omega we want theta calculation, so we have to move in this direction. Theta equals to minus infinite to t omega dt. If we apply, then we get here, we get instantaneous angle. Instantaneous angle. For instantaneous angle, result will be come from in this way. In instantaneous frequency, integration of instantaneous frequency from minus infinite to t omega c dt plus kf is constant, come out of integration mt dt. Now we further solve this expression, we get omega ct, because omega c is constant here and all value start at 0 location, so put integration and get result kf minus infinite to t m alpha d alpha. Due to same value at limit, so we change the variable. Change of variable does not affect anything, but limit does not change. We can say in this way, minus infinite to infinite xt dt is equals to minus infinite to infinite x alpha d alpha. Both are same because change of variable does not affect on value for this type of indication. Our basic expression for carrier is a cos omega ct plus phi, means unmodulated carrier we can denote in term of angle. Modified angle, instantaneous angle we get from here. So apply as per definition. Now we get complete expression for FM waveform is this term apply directly here. Kf minus infinite to t m alpha d alpha is complete expression for FM. From definition we have this much of correction amount from unmodulated carrier. Correction amount is kf integration minus infinite to t m alpha d alpha. This is correction amount. We can calculate frequency deviation also. Frequency deviation already discussed. Maximum frequency deviation is already discussed. Kf mt maximum. We want to calculate, if we want to calculate maximum frequency, which is omega c plus kf mt, minimum frequency omega c minus kf mt, if mt in both the direction, symmetrical wave pattern. And the second component we can calculate phase deviation. Phase deviation come from this expression. This component subtract from this phase. Instantaneous phase subtract from this omega ct basic phase, because this phase is always, if time reference 0, this phase is always available. This is the basic phase. Then phase deviation kf m alpha d alpha, we can maximize it in this way. Maximum phase deviation. Now we get two quantity, maximum phase deviation, maximum frequency deviation, and third one is expression. Expression of FM waveform is come from instantaneous by putting instantaneous angle value. I rewrite this expression. XFM equals to a cos omega ct plus minus infinite to t k alpha kf m alpha d alpha. Now completed. This is FM expression as per definition. Now we will consider MT, message signal. If message signal is single tone, cos omega mt, single tone frequency, message signal is single tone, single frequency, and then we can get these three parameter waveform expression, maximum frequency deviation and maximum phase deviation, and last value we can calculate beta also. First we write expression for FM waveform. If single tone message signal is applied, directly apply here. XFM a cos omega ct plus kf am cos omega mt dt. XFM is a cos omega ct plus kf am omega m sin omega mt. This component is denoted as beta. We'll later discuss modulation index. This is correction amount. Compare with unmodulated. If we correct add this much of correction amount, it is known as FM. Second term is maximum frequency deviation. Maximum frequency deviation come from this expression m alpha d alpha. This term we already solved, and for maximum frequency deviation I write down a formula. Oh, this is the instantaneous angle. I write down a formula kfmt max. kfmt max. Maximum frequency deviation is kfmt max. By putting value kfmt am cos omega mt max kf am. Maximum value of this is am only, because cos has maximum value is 1. Maximum frequency deviation is kfmt. Now maximum phase deviation is with formula for maximum phase deviation is kf minus infinite to t m alpha d alpha. Kf value of integration is am sin omega mt upon omega m. Maximum value of this, for maximization, maximum value of this is kf am upon omega m. Maximum value of sin is 1. We conclude for single tone expression is a cos omega ct plus kf am omega m sin omega mt. Maximum frequency deviation is kf am. Maximum phase deviation is kf am omega, and beta is, definition of beta is maximum frequency deviation upon modulating frequency. I write down expression again in mathematical term. I put these two value for single tone omega, which is same as phase deviation. I can put this value replace with beta, then final expression for FM waveform is omega ct plus beta sin omega mt. Close. We can say beta is kf am omega m, means modulation index depends on modulating frequency and as well as amplitude of message signal. Now we will discuss FM generation scheme. In the FM generation, there are two basic ideas: direct method and indirect method. Direct method and indirect method. Direct method is mostly used method, and indirect method is Armstrong method. Armstrong method. In the direct method, we are generating FM directly. What is the idea for direct generation? Apply input message signal, we directly generate FM signal. No intermediate step is involved in this. For FM generation, we use voltage control oscillator because FM is basically amplitude variation converted into frequency variation, corresponding frequency variation. If no amplitude variation means carrier component. This conversion via voltage control oscillator VCO. So direct method is used. Direct method consists a VCO. VCO is voltage to frequency converter. Voltage to frequency converter. Oscillator. It is oscillator means there may be a combination of L and C. This combination may consist different type of cases: Hartley oscillator, Colpit oscillator. If we consider, it might be a Hartley compact pattern. There is a Hartley oscillator, a combination of L and C attached with a device which have variable capacitance. Variable capacitance as per applied voltage exists in varactor diode. A varactor diode applied in a reverse bias applied on varactor diode will give result in variation in its reverse bias junction capacitance variation. This junction capacitance variation due to width variation in reverse bias. Width variation is directly proportional to applied voltage, which vary the capacitance. The variation of the capacitance can be converted into frequency variation. Linear variation in the capacitance of varactor diode converted into frequency variation. For frequency variation, we use some formulas. L1 and L2, some frequency component C dash come from this varactor diode. In second case, F2 case means linear range of the capacitance variation is required. 2 pi is not part of root. C2, this linear variation is required. So instantaneous frequency we can mark here in this way: omega c plus kfmt. Omega c plus kfb. Omega c minus kfb. Apply square wave on it and a trigonometric waveform, and result is variation in the frequency as per message signal magnitude. as per message signal magnitude. Message signal vary between two level, frequency variation also vary between two levels. Second method, in the first method, some uh, advantage point is attached with this and some drawback point also. Advantage of this method is it have very low amount of harmonic as compared to Armstrong method, low amount of harmonic distortion. In second case, uh, advantage point and disadvantage is poor frequency stability because low power is involved in this method because diode is used. So poor frequency stability. Poor frequency stability.